Good afternoon, everyone, and welcome to the third solving session. So, today we will be solving the problems from week three, that is energy and power. And as always, I hope everyone is ready with their paper and pen to keep on solving the questions all along. So the format will be similar. I will give some time to solve the question and then we will discuss the solution. So let's start with the first question. So it is there on your screen. So you need to determine the power that is being delivered by the current source in the below mentioned figure. Please try it out. And if you are done with the question, you can paste your answer in the chat window. Okay, so let's continue with the solution of this problem. So we need to find the power delivered by the current source. Now, as we know, for let's consider a simple circuit. For example, a current source of some current is pushing the current into some resistor. Okay. Now you guys know that whatever power the current source is delivering, that will be absorbed by the resistor. So now see, the power absorbed by the resistor is, let's say this is R and the voltage developed across this is V is equal to I times R. So the power absorbed by the resistor is uh, V times I. Now you please notice the direction of the current. Current that is flowing in the passive component, that is the resistor, is through the positive terminal. Like where the developed voltage has the positive terminal, there the current is flowing into it. And the similar voltage will be developed across this current source also. And here you see that the current that is going out of this terminal, the element that is delivering power, there the current is flowing out of the positive terminal. So keep this in mind. This convention is known as the passive sign convention. So according to this, we will find the power delivered by the current source. Now, the equivalent resistance that this current source will see will be 8 by 9 kilo ohms, and the voltage developed will be 9 milliamps into 8 by 9 kilo ohms. So, the power delivered will be 9 milliamps into 8 volts. That comes out to be 75 milliwatts. Now, can anyone tell what will be the power absorbed by the current source?
minus 72.
Yeah, correct. So, if some element is actually delivering the power, and you are asked in the question what is the power absorbed by that element, that power will be negative. And vice versa is the case with a passive component. Let's say it is absorbing the power, and in question, if it is asked how much power is being delivered by that element, that power delivered will be negative. So keep this sign conventions in mind. Now, this is the second question. Please try it out. So, guys, please don't unmute yourself until and unless there is some doubt. Otherwise, other people will get disturbed. Okay, so let's try to see how to solve this question. So, what is mentioned in the question is that you have a network that consists only of resistors, and when you apply an 8-volt voltage source to this, that consumes 1.28 joules of energy in 1 minute. And what is asked in the question is what will be this current I1 when a 24-volt voltage source is applied to the same network. Okay. Now, if the network is consuming 1.28 joules of energy in 60 seconds, that is 1 minute. So the power that this network is absorbing is the energy divided by the time in the seconds, and that comes out to be 1.28 by 60 watts. And so from here, what you can find is like what is the current that will flow in this case, right? So the power is again V into I. That let's call the current this current as I8 when 8 volt voltage source is applied to it. So power is V into I, and the current comes out to be power divided by the voltage. Okay. Now, this is the current that flows into the network when 8-volt voltage source is applied. Now, when the 24-volt voltage source is applied, that is basically 3 times 8. What will happen? The current will also increase by 3 times. That is flowing into this resistive network. So that will be 3 times I8, and that comes out to be 8 milliamps. Any doubt in this? So if there is no doubt, we will move forward. So this is the third question. Please try it out. Okay. So please try this question, and if you are done, please paste your answer in the chat window. Okay, so let's see how to solve this question. Now, in the question, it is asked that determine that energy that is delivered from voltage source from time t equal to 0 to time t equal to 3 microseconds in the figure given, and the initial condition for this inductor is given as IL equal to 0. Okay, so first of all, the energy that is delivered for to calculate the energy that is delivered. So any element that delivers energy or power, for that we need the current should go out of the positive terminal of that element. So in this case, the current's direction should be coming out of the positive terminal of 8 volt voltage source, and the energy that will be delivered by this 8 volt voltage source will be the integration of the power that is delivered by this voltage source from 0 to 3 microseconds. And since the power is equal to V into I, and the voltage is constant, so what we need to do is we need to integrate the current that is flowing out of this voltage source from 0 to 3 microseconds. Now, the current I will be equal to IL minus I1 from KCL at this node. Okay, so now what will be the IL? So IL will be, so current through the inductor is basically, so how current and voltage in the inductor are related is through this equation, that is current through inductor is 1 upon inductance and in the integration of the voltage across that inductor. Now, since the voltage across that inductor is a constant, so the overall current that will be flowing into the inductor will be 1 by inductance, that is 4 microhenry into 8 times T, and 8 is the voltage, so that comes out to be 2 into 10 to the power 6. So what we have over here is the I1 I1's curve is given in the question up to 3 microseconds, and the current that flows through the inductor will be a ramp current that will increase with a slope of 2 into 10 to the power 6. And since time is in microseconds, so from 0 to 3 sorry, it will be 6. So from 0 to 3 microseconds, the overall current that will come out, that the inductor will develop will be 6 amperes. And yeah, from there, if you calculate what is the waveform of the current I, so for 0 to 1 microsecond, the current I1 is in has a positive slope, as well as I2, the IL also has a positive slope. And since I is equal to IL minus I1, so these two will cancel, and we will have zero current in this duration. and from 1 microsecond to 3 microsecond, the current will increase constantly, and that will increase from 0 to 8 amperes. So from here, if you calculate, so this is the graph of the current I, and to calculate the energy, you needed to integrate this current. That is basically the area under this curve. So if you calculate it, it comes out to be 8 into half into, so half into base into height, that is the area of this rectangle, and that comes out to be 64 microjoules. Any doubt in this?
Sir, one more time repeat it.
Okay. Uh, okay. So can you please explain like what part you were not able to explain, Mosam? What part you were not able to understand?
Sir, graph.
Okay, the graph part. Okay, so fine. You understand this that the current that is coming out of this 8-volt voltage source is equal to IL minus I1. Okay,
Yes,
so
sir.
yeah, so now for time equal to 0 to 1 microsecond, IL is moving from 0 to 2 amperes, and I1 is also moving from 0 to 2 amperes. So these two currents are identical. Okay, so in this particular time, no current will flow from this 8 volt voltage source, because all the current that flows into IL is being supplied by I1 itself. So and after that, since IL is increasing in positive direction with a slope of 2 ampere per microsecond, and I1 is reducing in negative direction with a slope of minus 2 ampere per microsecond. Sorry, with a slope of minus 2 ampere per microsecond. So the total current that I1, that this 8 volt voltage source will be supplying will, since it is difference of IL minus I1, so the I will increase at the slope of 2 minus of minus 2, that is 4 ampere per microseconds. Now, for what time? From now, since it is increasing at 4 amperes per microsecond, and it is increasing for 2 microseconds, so it will increase from 0 to 4 into 2, that is 8 amperes. So this is the graph that you get for I. And now you integrate the area under this curve. Is it clear?
Yes, sir.
Okay. Now, please try out this question. So here you need to find the power that is delivered by this 6-volt voltage source.
Hello.
Okay, so we have 228 as well as minus of 228. So let's see which one is correct. So first of all, we need to, so again, what we need to do is we need to find the power delivered by the 6 volt voltage source. So we need to find the current in this direction. Okay, that is coming out of the positive terminal. Now, if you look closely into the circuit, KCL at this node will give you the current in this branch as 16 amperes, and KCL at this node will give you the current in this branch as 22 amperes. So 22 amperes and 16 amperes will flow, and then KCL at this branch will give current in that is flowing into the positive terminal of a 6 volt device, and that comes out to be 38 amperes. So this particular element, in actual, it is absorbing power and it is not delivering power. So if you need to calculate the power that is delivered, for that you will have to see what current is flowing out of the positive terminal of this 6 volt current voltage source, and that is minus of 38 amperes. So the power delivered will be minus 228 watts, and it won't be 228 watts. So please keep in mind like what is asked in the question, if it is power absorbed or power delivered, and accordingly you have to take care of the sign. Any doubts in this?
No, sir.
Okay, so now solve this question. So we have quite a few uh, variations of the answer. So let's see how to solve this. Now, again, what is asked in the question is power delivered. So for power delivered, since the current's direction is this, so now this is the opposite of what I have been talking about so far. I've been talking about a voltage source that for voltage source, if you need to calculate power delivered, you need to find the current that is flowing out of the positive terminal. Now, in the case of current source, let's say in whichever direction the current is, the voltage, you need to find the voltage developed so that the same convention is maintained. That is, current flows out of the positive terminal. So you need to find VI. Okay. So VI will be equal to negative of this voltage, as this voltage is in opposite direction, and that will be 2 into 10 to the power 3 into 8 milliamps. That is the IX current flowing in this direction, and that comes out to be minus 16 volts. So if the voltage is minus 16 volts and the current that is flowing is 8 milliamps, so your power delivered is minus 128 millivolts. Okay. And again, now since it is minus 128, that means in actual this 8 milliamp current source is absorbing power and not delivering power. Okay, now solve this question. So this is an lossless LC tank circuit, and the voltage across the capacitor is given in this graph, and you need to find the energy that is absorbed by capacitor up to time equal to T by 4, T by 2, 3T by 4, and T. So just paste in the chat box with option A, B, C, or D, whichever you think is correct. Okay, so let's see how to solve this question. So uh, we know that energy stored in a capacitor is a function of the voltage across the capacitor, and that depends, and that is related with this relation, that is equal to half CV times C times V square. Okay, now up to T by 4, this energy, the energy that is stored is 1 by 2 into C into 1 square, that comes out to be C by 2. Now, up to T by 2, the energy goes 0. Now, what is happening is that, like, till this time T, this capacitor is being charged, uh, and it is storing the energy, and after that this capacitor starts to discharge, and in this time when the capacitor is discharging, that is converting the energy that is stored into the capacitor into the current, current that flows through the inductor, and that the electrostatic energy of this capacitor is being transferred into magnetostatic energy in the inductor. So by time t equal to 2, all of that energy is being transferred to the inductor. Hence, no energy stored in the capacitor, and the value is 0. Again, at t equal to 3t by 4, the energy becomes C by 2, and at the end of the cycle, and again the energy becomes 0. So the correct option is option number B. Any doubt in this? Okay, so the current that is the energy that is stored in the inductor is the so that is in form of flux through the inductor, and that is called magnetostatic energy, and the energy that is stored in the capacitor, that is in form of charge in the inductor, that is called electrostatic energy. It's similar to what you see in pendulum. Let's say you might have learned it in physics, high school physics, that if the pendulum swings, the energy keeps on oscillating between the kinetic energy and potential energy. So that's how this also works. Mosam, do you have a doubt?
No, sir.
Okay, you raised your hand. I thought you had. Okay, fine. Okay, so now in this question, what you need to do is uh, you have been given a voltage curve across a 2 microfarad capacitor, and what you need to find is what will be the power curve for this particular capacitor. And you have four options: A, B, C, and D. So please try it out and paste your answer in the chat box. Ayush, please try to rethink uh, if it's option B or not. Okay, let's see how we solve this problem. Now we are asked the power curve, and we know that power is equal to voltage into current. Okay. Now we know the voltage of the voltage across the capacitor, and we know that the current across the capacitor so current IC is equal to C dV by dt. So what we have is when the voltage is this thing, the current is capacitor times the derivative of this curve. Okay, and now from 0 to 2 seconds, this voltage is constantly increasing. The current will be nothing but capacitor times the slope of this curve. Okay, so that comes out to be so the slope is 1 for this, and the capacitance is 2 microfarad. So the current is 2 microamperes in this section, and for the section from 2 to 4 seconds, we have the slope is -2. Slope is equal to -2, and the capacitor is again 2 microfarad. So the current is -4 microamperes. Now we are to multiply these two curves, and if we multiply it, so from 0 to 2 seconds, this curve is this straight line is getting multiplied by a constant of 2. So since the voltage was increasing from 0 to 2 volts, the power will increase from 0 to 4 microvolts. And then there is a sharp uh, there is a sharp discontinuity in the current curve, and just after 2 microsecond it will be minus 4 multiplied by 2, that is minus 8 microwatts, and then it will keep on increasing till 4 seconds, and where it will go again minus 4 times minus 2, that is 8 microwatts, so it will increase to 8 microwatts like this. So this is the total curve, and this matches with option number C. So this is the correct answer. Any doubt in this?
No, sir.
Okay. So now we have this question that the capacitor of 2 microfarad is being charged from 0 to 800 microcoulombs. So what will be the maximum energy stored in the capacitor? If you have figured out the answer, you can paste it in the chat window. Okay, so let's see what is the solution. So energy that is stored in the capacitor is half CV square, and so this will be maximum when the voltage developed across the capacitor is maximum, and that will be when the charge stored in the capacitor is maximum. So V max is equal to Q max by C. That comes out to be 400 volts. And from there, if you calculate the maximum energy, you get as 0.16 joules. Any doubt in this? So let's move to the next question. So you need to find the power. So this is a part of a network that is mentioned in the question, and the voltages developed across the elements and the current through the elements are mentioned over here, and you need to find the power absorbed in element 1, element 2, and element 3. Okay, so let's see and solve this problem. So now again, please keep in mind the conventions that we have discussed earlier. So at all the times, we need to find the power that is being absorbed in the elements. So in the first case, the voltage that is developed is given as V1, and the current is going out of the positive terminal of V1, that is I1. So the power absorbed, if you want to calculate, that will be minus of V1 times I1, and V1 is given as 5 volts, and I1 is given as minus 10 amperes. So the power absorbed is minus of 5 minus 10, that is 50 watts. Now for element 2, the voltage developed is given as V2, that is equal to minus 5 volts, and the current the current that is being uh, pushed into the positive terminal is given as, you can calculate I2 over here from the KCL at this node, that comes out to be 5 ampere. So the power absorbed will be V2 times I2, and that comes out to be minus of 5 volts times 5 amperes, that is equal to minus of 25 watts. And now in element 3, similarly, the voltage is given as 10 volts, and the current that is going into the positive terminal is given as 15 amperes. So power absorbed is V3 times I3, that is 150 watts. Any doubt in this? Okay, so let's move to next question. Now, in this question, you need to calculate the energy that is absorbed by the capacitor and energy that is absorbed by the resistor, both in millijoules. And what is mentioned is, the capacitor is first charged to 20 volts and then put in this circuit. So initially there is 20 volt, initially there is voltage across the capacitor is 20 volts, and then it is plugged into this circuit. So after a long time, eventually what will be the energy absorbed by the capacitor and the resistor? Okay, so let's see how to solve this. Now, what will happen is, whatever voltage is initially this capacitor is charged to, that will get dissipated through this resistor in form of heat. And now how is it going to happen is that the capacitor, capacitor basically will discharge through this resistor. So capacitor will deliver the energy, and the resistor will absorb this energy that is being delivered by the capacitor, and that will be dissipated in form of heat. So energy that is absorbed by the capacitor is initially it's charged to half CV square, and that finally it will be to zero. So energy absorbed will be minus of half into C times V square, that is minus 2 millijoules. And the energy absorbed by resistor will be the positive energy, since it is actually absorbing the energy, that will be 2 millijoules. Any doubt in this? Okay, so let's move on to next question. So here, this inductor is initially energized with a current of 2 milliamps, and then it is connected in a short circuit. So you need to find what will be the current through this inductor after 24 hours. Okay, so in this question, now, yeah, so in this question, there is no energy absorbing or energy dissipating element in this particular loop. So the inductor will retain its current. So what you need to also the current, no matter how much time passes, it will be 2 milliamps. So what you need to keep in mind is when capacitor is open circuit, it retains charge and hence the voltage, because Q equal to C times V. And when the inductor is short circuit, it retains current and flux, that is phi is equal to Li. So there is no place for this I to get dissipated. So the flux and current are retained in the inductor. So these two conditions you must keep in mind to solve further questions. Like, yeah, in the future. Now, so this question here you need to find the power absorbed by the power absorbed by the 8-volt voltage source, 8-volt battery in milliwatts. Okay, so let's try it out. So again, the power that will be absorbed by the voltage source will be minus of Ix times 8, because Ix is coming out of the positive terminal of this voltage source, and the power, to calculate the power absorbed, you need to see the current that is flowing inside the positive terminal of this voltage source. Now, uh, so for calculating this Ix, you can apply the Kirchhoff's voltage law in this bigger loop. So that will be 8 volts minus of the voltage developed across 1 kilo ohm resistor, that is Ix into 1 kilo ohms, minus 2 volts minus the voltage developed across this, that is 2 times Vx. And since Vx is 1 I times 1 kilo ohm, so it's minus of 2 times Ix times 1 kilo ohm. So from there you calculate Ix as 2 milliamps. So power absorbed will be minus of 16 milliwatts. So yeah, this was these were the questions from my side. Now, do you guys have any other specific doubts?
Sir, can I ask a question from the week 2 assignment? I have a doubt in that.
Okay. Week two assignment. Okay. So yeah, what is it?
Sir, I'm sharing my screen.
Okay, you can share your screen.
Sir, this is the question. Question number 6.
Okay. So what is asked in the question is, you need to find for the given circuit IA, B, C, and the voltage across 4 kilo ohm resistor. Okay. Okay. So yeah. So have you tried this question? So I also saw this question. Actually, you need to have either IA or IB or IC known. Then only you can solve this question, or the voltage at one of the lower terminals. I
Yes, sir.
also saw this.
One equation was missing. I was only
Yeah,
able to.
yeah.
Yes, sir.
So you have four unknowns and only three questions were. So what you can try it out is. So from the solution, from the question itself, from the options itself, if we try to see, so which option does actually make sense. So if we look it that way, then so from the this particular complete network, that is 1 kilo ohm, 3 kilo ohm, 2 kilo ohm, 4 kilo ohm resistor, these are connected. So in this case, what the currents 5 milliamp, 3 milliamp, IC and IB, their sum must be equal to 0 because of the KCL. So let's see which of the options has that particular thing. So from there, yeah, from there either it will be option A or option D, right? Because 5 plus 3 milliamps is 8 milliamps, and the IB plus IC also must amount to the negative of the same sum. So either it will be option A or D. So in both the cases, you have 5 milliamps, and the current IB and IC are same. So you can use
Yes,
these currents, and then you can proceed forward. So yeah, if
sir.
the options were not given, then you couldn't have solved this question. But yeah, options are given in such a way that only one of the options will make sense.
Sir, can it happen in like gate exams, like this type of question come without sufficient information?
Yeah, if that happens, that sufficient information is not there. So here, like from the options, you can deduce what will be the answer. Okay, so this is still fine, but if let's say this was a numerical type question, then you would have got grace marks if the question was unsolvable.
Yes, sir. Yes. Thank you, sir.
Okay, any other doubt? So if there are no other doubts, then we can hang up. So this was it from my side. Thank you for attending.
Thank you, sir.
Thank you, sir.
Thank you.